So in general, the product of denominators will result in a common denominator. But the key thing to remember here is that you can get a common denominator, but it may not be the least common denominator. So it will give us a common denominator, but not necessarily for example, suppose we had 1/2 and we have to add it to 1/4. Now you can immediately say, oh, I'll just take the two denominators, I'll multiply, and the common denominator would be 8. But is it the least common denominator? Well, the least common denominator in this case is not 8, rather it is 4. So the first term is 2. I could write it as 2 times 1. The second term is 4, and 2 times 2. Now, you want to keep on looking for a value that would form the least common multiple. So the next one would be 8. So you have 2 times 2 times 2. You can see that 2 is a part of every single term, but 2 times 2 is also in that number. In other words, we have accounted for the least common multiple already. So the least common denominator is 4. So the objective now is to extend this basic concept to variables or rational functions that don't just have numbers, rather you have expressions. Let's say we have 1/a and 1/b. And we just want to add, clearly a and b are not the same. So the least common denominator in this case would simply be a times b. Suppose we have 1/2a and 1/a. Now, one of the common denominators is simply 2a times a, which is 2a squared. But 2a squared is not the least common denominator. It is a common denominator that would help us in solving the problem, and I'll show you how, but it's just not the least common denominator. The least common denominator in this case is just 2a. So suppose I use the common denominator 2a squared. To get to a squared, I would multiply and divide the first fraction 1/2a by a. So we have a over 2a squared. Plus, I need to get a 2a squared in the denominator of this second fraction. So I'd multiply and divide by 2a. So I have 2a over 2a squared, which would give me an answer as a plus 2a divided by the common denominator, 2a squared. I will have 3a over 2a squared. The a can be cancelled, and I'll have 3/2a. But if I use the least common denominator, then all I have to do is to get that 1/2a in the second fraction. I could easily do that by multiplying and dividing by 2. So I have 2 over 2a. I have a common denominator, 2a. So I simply add the numerators 1 plus 2, which is 3. And you can see I get the exact same answer, but clearly, if you use the common denominator, it is going to result in extra steps and unnecessary simplification. But if you pick the correct least common denominator, then the problem is pretty straightforward. So here is an example, and lucky for us, we have x times z squared and x times z squared. The denominators are identical. So we have a common denominator. So we can write that as x times z squared and simply combine the numerators, which in this case would be 2 minus 5. The answer is negative 3 over x times z squared. So if we have a common denominator, everything is straightforward. So in the second problem, we have x squared over x plus 2 minus 4 over x plus 2. We have a common denominator, which is x plus 2. So we can combine the numerators, which should be x squared minus 4. Now, you may say, well, that is the answer, and I can just stop. But you should always ask the question about simplifying, because I mentioned in the last video that anytime we have division of polynomial expressions in a rational function, one of the things that we need to do is to check for common terms that we can cancel out. So the numerator is of the form x squared minus 2 squared, which is a special product. So I can write it as x plus 2 times x minus 2 divided by x plus 2. X plus 2 would go away, so the answer is simply x minus 2. So we have a common denominator, so life is easy in this problem. So the common denominator is 4x. The first fraction has x plus 4. It's good practice when we deal with subtraction and we have multiple terms, using parentheses would help us keep track of the signs. So we have minus the second numerator, x minus 4. X plus 4, distribute the negative, you have negative x. Negative times negative 4 is positive 4. The x's go away. 4 plus 4 is 8 over 4x, and 8 is divisible by 4. So we have 2 divided by x. So here is a problem which seems a bit complicated, but I would assure you that this problem is actually easy. Even though we have a trinomial in the denominator, it's still the same denominator, so there isn't a lot of work that we need to put into this problem. So I have a common denominator, so that is x squared plus 2x minus 8. I can simply combine the numerators, 5x plus 2 plus 2 minus 4x. Since I have a positive sign in the middle, the parentheses were just optional, but it's good practice though. 5x plus 2 minus 4x divided by x squared plus 2x minus 8. 5x minus 4x is x, and 2 plus 2 is 4, divided by x squared plus 2x minus 8. Now, we want to know if we can factor the denominator. I think we can. So the denominator can be factored as x plus 4 times x minus 2. The x plus 4s will get cancelled, and we have 1 over x minus 2. Since you're learning in this course, we do the assignment or the homework, the numerator that you arrive at, for example, after simplifying, ended up getting x plus 4. So it immediately prompted in my mind, well, perhaps I can get rid of x plus 4. We design the problem in such a way so that you have better practice. So always ask the question, well, I have a lengthier polynomial in the denominator. I have a factor of x plus 4 in the numerator. Is it feasible for me to write the denominator polynomial in terms of x plus 4? And if it is feasible, then we can cancel out common factors and simplify the way I just did, which is 1 over x minus 2. So now we have to come up with the least common denominator of each rational expression in the list. Now, keep in mind, a common denominator is simply 5y multiplied by 4y squared, which would be 20y cubed. If you multiply the denominators of two rational expressions, the resulting answer is definitely a common denominator. But now the question is it the least common denominator? So when we have numbers and variables, first we look at whatever term that could be common between the numbers. So LCD of 5 and 4. Clearly there is nothing common between 5 and 4, so we just multiply the two to get 20. Then we go to look for the common denominator of y and y squared. So y is simply y times 1, and y squared is y times 1, and y is in the next expression, and the only way we could get a common multiple is if we had y squared. So the least common denominator for those two would be y squared. So the LCD of 5 and 4 is 20. The LCD of y and y squared is y squared. So what is the final LCD, which is the LCD of 5y and 4y squared? It is simply the product of the two individual LCDs, 20 and y squared. So we have 20y squared. So here we have an example where we have 3a plus 9 and we have 5a minus 15. So first, pull out a common factor. Well, the common factor between 3a and 9 is 3. If I pull that out, I have 3 times a plus 3. And I'll move on to 5a minus 15. I have a 5 in common, so if I pull out 5, I end up having a minus 3. Now I just have to compare those two terms. I've realized that there is nothing in common between 3 and 5. So if I have to find that least common denominator for the two numerical parts, it would simply be 3 times 5. And there isn't anything common between a plus 3 and a minus 3. So we simply have to write it as a plus 3 times a minus 3. So the least common denominator is 15 multiplied by a plus 3 multiplied by a minus 3. You may either leave it as is or use the special product and recognize that a plus 3 times a minus 3 is simply a squared minus 3 squared, which should be a squared minus 9. So the key here is to write the individual factors. If you go back to the previous problem, the very first thing that I did is pull out the common terms so I get a better picture of the factors that are in each of those denominators. So factoring is key. So we'll start with x squared minus 9. We have seen a couple of times today that x squared minus 9 could write it as x plus 3 times x minus 3. The next term is x by itself. So I'll simply have x. There's nothing I could do about it. I'll just write it as x times 1. The next term is 12 minus 4x. We want to see if there is a common factor. Well, 4 is a common factor, so I can pull 4 out and I'll have 3 minus x. This is where we've got to use a little bit of thought. I look at 3 minus x and I see an x minus 3 in x squared minus 9. So maybe, or it's not maybe, definitely I can rewrite x minus 3 as 3 minus x, or 3 minus x as x minus 3 if I pull a negative out. So if I put a negative out, I would have negative 4 times x minus 3. So I have nicely factored each of the denominator terms. Now I'm going to go and hunt for the common multiple so that I have a least common denominator. We'll start with the numbers. I see a negative 4 here. Negative 4 is missing in the other two terms, which would imply, in order to form a least common denominator, I need to have a negative 4. The next term would be x minus 3. I have x minus 3 here, x minus 3 there. The second denominator, x, doesn't have x minus 3, so that should be a part of the LCD also. X plus 3 is in the first term, x squared minus 9. It is missing in the other two, so we've got to put that in there also. In a similar manner, x appears in one of the denominators, missing in the other two, so we'll have to put that term. So you can see I have x minus 3 in common between the three denominators, and it was missing in one of them, which is why I simply threw that x minus 3 in there. Same logic with x as well. So we would have negative 4 multiplied by x minus 3 times x plus 3. We know x minus 3 times x plus 3 is x squared minus 9. Now, in a problem like this, if they're asking for the LCD, the way to write the answer would be minus 4x times x squared minus 9. But if you're trying to add polynomials and rational functions, it is best to keep it in this factored form so that you can try to see if you can get rid of terms by simplification and by cancelling terms in the numerator and denominator. So if we're trying to add terms together, it's best to retain LCD in the factored form so that there could be a possibility to cancel terms out between the numerator and the denominator and simplify the answer properly. Okay, so the first step is to factor. So we have a squared plus 8a plus 16, which is a plus 4 squared, but it is best to write it as a plus 4 times a plus 4, so you can visually see the factors. A squared plus a minus 12 would be a plus 4 times a minus 3. So we see a plus 4 in both of those terms. So that is in common. So I can write 1a plus 4. Then I see a minus 3 in 1. I do not see another a minus 3 or a minus 3 in the other factor or other term. So I'm going to put a minus 3. Here is the key thing to note. If you have a common factor, let's just say, let's say we have a plus 4 and the other one we have a plus 4 times a plus 4. So those two are the same, but one of them has a higher power. So when we form the LCD, if we have identical factors, you put the one with the higher power. Does that make sense? So let me pause the. So we want to add those two rational functions, and I'll look at the problem. One denominator is 5 minus x, the other is x minus 5, and I immediately recognize I could take one and write it in terms of the other. So first step, I'm going to rewrite the first denominator. If I pull a negative out, I have x minus 5 plus x plus 2 over x minus 5. And one may argue, well, we have different terms here, so I just have to multiply them to get the least common denominator. That is not true. If all we have is negative 1 in the denominator, I can move that negative to the numerator, and I could rewrite it as negative 3 over x minus 5 plus x plus 2 over x minus 5. So I have a common denominator already, and that is x minus 5. So I put the common denominator, which is x minus 5, and simply combine the numerators. So I have minus 3 plus x plus 2. X is by itself, minus 3 plus 2 is minus 1. So we have x minus 1 over x minus 5. We can't simplify this any further, so we will just leave it as is. So we have one denominator as x minus 2, the other is 2 minus x. By all means, they are the same with sign switched. So we could do the same trick like the previous problem, have 5 over x minus 2. I'm going to pull a negative out. So now we have negative times that positive, which would make that middle term negative. And we have a common denominator, which is x minus 2. So the first term is 5 minus x plus 4. And it's good to have those parentheses, because if you use parentheses, well, you won't mess up with signs. So we have 5 minus x minus 4 divided by x minus 2. And 5 minus 4 is 1, so we have 1 minus x over x minus 2. We cannot simplify this any further, so we can leave it as is. So here we have 3x squared plus 11x plus 6. We have to factor. And how do we factor? We have the middle coefficient as 11. So we have to come up with two numbers so that when we add, we get 11. When we multiply the two numbers, we get 18. So I am going to say that the two numbers are 9 and 2. If I add the 2, I get 11. If I multiply 9 to 2, I will get 18. So looks like I have the correct two numbers. So 3x squared plus 9x plus 2x plus 6. Now we have to do the usual step of getting a common term from the first two terms. Between 3x squared and 9x, the common term is 3x. If I pull that out, I have x plus 3. In the last two terms, 2x and 6, I have a 2 in common. If I pull that out, I have x plus 3. X plus 3 is in common now. So if I pull that out, I would have 3x plus 2. So I have successfully factored the first denominator, which is 3x squared plus 11x plus 6. Now, the next denominator is 2x squared plus x minus 15. I need to multiply. Sorry, I need to come up with two numbers so that when I add, I get 1. When I multiply, I get 30. So the two numbers are 6 and negative 5. So 6 minus 5 is 1. 6 times negative 5 is negative 30. So we would have 2x squared plus 6x minus 5x minus 15. Pull the common term out of the first two terms. If I pull 2x out, I'll have x plus 3. Last two terms, if I pull a negative 5 out, I would have x plus 3. So I have x plus 3, x plus 3. So if I pull x plus 3 out, I have 2x minus 5 behind. So I've factored both denominators. Now we have to go and look for the LCD. I have an x plus 3 in common, so x plus 3 is one factor. And I have 3x plus 2 in one. It's missing in the other, so 3x plus 2 has to go in there. I have 2x minus 5 in one. It's missing in the other, so I must have 2x minus 5. So the LCD is x plus 3 times 3x plus 2 times 2x minus 5. So we go back to the addition part, and I'm going to rewrite the rational function as x plus 4 divided by the factored form, which is x plus 3 times 3x plus 2. Same with the other term. The factored form is x plus 3 times 2x minus 5. We have the LCD from above, and you can see the first denominator is missing 2x minus 5. The second denominator is missing 3x plus 2. So I'm going to multiply and divide by 2x minus 5 with the first fraction. I'm going to multiply and divide by 3x plus 2 with the second fraction, or rational expression. And now you can notice that I have the common denominator that I was looking for. So since we have a common denominator, running out of space, I could put the common denominator that I have, which is x plus 3 times 3x plus 2 times 2x minus 5, and combine the numerators, which would simply be x plus 4 times 2x minus 5 plus x times 3x plus 2. It is always a good idea to distribute and try to simplify, because things might get cancelled. So if I FOIL the first term, I would have 2x squared minus 5x plus 8x minus 20. Distribute the x in the last two terms, I'll have 3x squared plus 2x, and divide that by the common denominator we had, x plus 3 times 3x plus 2 times 2x minus 5. 2x squared plus 3x squared would be 5x squared. 8x plus 2x is 10x. 10x minus 5x is plus 5x. And lastly, I have minus 20. Divided by the common denominator, x plus 3 times 3x plus 2 times 2x minus 5. Could this be simplified further? We have a common factor in the numerator. I'm just going to use space from here. So if I pull 5 out, I have x squared plus x.
I figured.
Okay, so I have the 5 in common, so if I pull 5 out, I have x squared plus x minus 4. Divided by x plus 3 times 3x plus 2 times 2x minus 5. That cannot be simplified further. In other words, I can't factor the numerator. We have to come up with two numbers. If we add, we get x. If we multiply, we get negative 4. I don't think those two numbers are feasible. So that is the final answer. That's the best that we could do. So the first denominator is x squared minus 8x plus 7. We want to factor it. So two numbers, when we multiply, we need to get positive 7. When we add, we get negative 8. So the two numbers are negative 1 and negative 7. So we have x squared minus x minus 7x plus 7. In the first two terms, we have x in common. So if I pull x out, I have x minus 1. In the last two terms, we have negative 7 in common. If I pull that out, I have x minus 1. This way, I have x minus 1 in common. So if I pull that out, I have x minus 1 times x minus 7. So that is the factored form for the first denominator. Now we've got to do the same with the second denominator, which is 2x squared minus 9x minus 35. So I need to come up with two numbers so that when I multiply, I get the product of 2 and negative 35, which is negative 70. And when I add, I get negative 9. So the two numbers are negative 14 and positive 5. Negative 14 plus 5 is negative 9. And if I multiply negative 14 and 5, I would get negative 70. So I have negative 35. So 2x squared minus 14x plus 5x minus 35. In the first two terms, we have 2x in common. If I pull that out, I would have x minus 7. In the last two terms, I have 5 in common. If I pull that out, I have 5 times x minus 7. Now, x minus 7 is a common factor. So if I pull that out, I have 2x plus 5. Now we can come up with the LCD. There's x minus 7 in both terms. X minus 7, x minus 7. So x minus 7 is one factor in the LCD. The first denominator has x minus 1, the second does not. So that has to be part of the LCD. The second denominator has 2x plus 5. The first one does not. So that has to be part of the LCD as well. So we know x divided by x squared minus 8x plus 7 can be written as x divided by x minus 1 times x minus 7. There is a minus in the middle, x plus 2 divided by the factored form of the denominator, x minus 7 times 2x plus 5. Now we have to multiply and divide each fraction by an appropriate factor so that we end up getting the least common denominator between the two rational expressions. Then we can combine the numerator and simplify. Okay, so we have two denominators and they don't look alike. So we have to find the LCD first. So to do that, I have to factor that expression and that expression over there. So we all know x squared minus 36 is a special product. I could write it as x plus 6 times x minus 6. X squared plus 9x plus 18. We have to factor it. We have to come up with two numbers so that when we add the two numbers, we get 9. When we multiply, we get 18. So the two numbers are 6 and 3. So we have x squared plus 6x plus 3x plus 18. In the first two terms, we have x in common. So x, if I pull that out, I have x plus 6. In the last two terms, we have 3x plus 18 in common. Sorry, 3 in common. So if I pull 3 out, I have x plus 6. So x plus 6 is now in common. So if I pull that out, I'll have x plus 6 times x plus 3. So the least common denominator, I have x plus 6 as a factor in both terms. So x plus 6 is part of the LCD. I see x minus 6 here, but x minus 6 is missing in the other denominator. So x minus 6 is a factor. And I see x plus 3 here. X plus 3 is missing in the other one. So x plus 3 is part of the LCD. Now we have to rewrite each of those fractions. So I have x plus 2 divided by x plus 6 times x minus 6. X squared plus 9x plus 18, we've factored it as x plus 6 times x plus 3. To get the common denominator, I have to multiply and divide the first fraction by x plus 3. To get the common denominator, we have to multiply and divide the second rational function by x minus 6. So we have x times x minus 6 over x plus 6 times x minus 6 times x plus 3. We now have a common denominator, which I'm going to write it in a simple way. Since I know for a fact x plus 6 times x minus 6 is x squared minus 36, I can write it now as x squared minus 36 times x plus 3. And combine the numerators. We have x plus 2 times x plus 3 minus x times x minus 6. Distribute and simplify if it is possible. So we have x squared plus 5x plus 6. That is what we would get if we FOIL x plus 2 times x plus 3. There is a negative, so negative x times x is negative x squared. Negative x times negative 6 is positive 6x. Over x squared minus 36 times x plus 3. The x squares will get cancelled, 6x plus 5x is 11x and plus 6 divided by x squared minus 36 times x plus 3. And sadly, we cannot simplify that any further. So that's the best we could do because there aren't any common factors.